And this is there on Blackboard as well. Okay. So now let's look at let's try to understand the structure of SQL. So let's look at a simple query where, okay, to launch a query, you're going to click on this button here that says new query. So click on that button that says new query, and SQL statements have this structure: select from where. So typically your SQL queries have this kind of structure. These are keywords: select from where. What you put after from is the table that you want to select the data from. Your database may have, if you look at an ERP database, depending on the size of your company, how many products, it may have a very large number of tables. But you don't want an ERP, like I said, it encompasses all business functions. So you may have several hundred tables in your ERP database. You're not wanting to look at all those several hundred tables. Typically, you may be wanting to look at one or two tables, trying to grab the data from one or two or three or four tables. So what you specify after the from is the table that you're trying to obtain data from. So let's say I want to find out who are the people in the department of marketing. So the employee table has the information about the people in the company. So the table that I'm seeking to get information from, if I want to find out the people in the marketing department, is the employee table. So that's what you indicate after the from keyword. This is what your from clause is. Then after the select keyword, you're going to identify the columns that you want to see in the results set. So when you launch a query, the results are referred to as the result set. Now, what are the columns that you want to see? Again, a table may have many columns. Large complex tables may have 30 columns. Well, do you want to see all of those columns? Generally not. You want to focus on few columns. So maybe here we want to see in the results set name, maybe address, department, salary. So I just want to look at those columns. I don't want to look at date, joined, and other things, or the position or other things like that. So I just want to look at the columns, name, address, department, salary. The columns are specified right after the keyword select. The next clause, like I said, was the from clause, and that simply identifies the table that you're selecting the information from. We'll see at a later point in time, not today, we'll see how you can get information from multiple tables, and that is by joining the tables. And that's why I had two tables in this assignment, because I wanted to also demonstrate the joining of tables. But we won't get to that today. Okay, the where clause is for specifying the filter. In other words, when you're grabbing a set of records from a table, you don't want to see all of the records in the table. Your table may have 50,000 records. You don't want to see all of those records. You want to see a subset of those records. The where clause is used to define that subset. So it acts as a filter. It filters out from the mass of data that you have in the table. It filters out from that the records that you're interested in. So if I wanted to see people in the marketing department. I don't want to see all of my employees. I want to see the people in the marketing department who are in the marketing department. And I want to know what their name, address, department, and salary is. So this is how the query would be defined. Now that you define the query, you want to hit this execute button, and this will execute the query. So you hit the execute button, and you see here, this is the result set. The result set comes back. It's the result set indicates for you exactly who are the employees in the marketing department and what their name, address, department, salary is. Suppose I wanted to get this information for the employees in the MIS department. Well, simply change the filter, change the where clause, change this to MIS, and then hit the execute. And these will be the employees who are in the MIS department. Suppose I wanted to get more specific in the filter. In other words, I want to add more conditions as to who I want to see in the result set. So, for example, you wanted to see high-paying workers in, let's say, the MIS department. So people who are paid more than a certain salary. So you want to see people in the MIS department who are paid more than 85,000. So we are basically making the filter, or the where clause. The where clause is the filter. We're making this more granular or more specific, and we can add as many ands as you want to make it more and more specific. So if you wanted to see people in the MIS department making more than 85,000, then simply specify a where clause where you're adding both of these conditions. And then if you did the execute, well, now you see a smaller result set. And these are the only two people in the MIS department who have a reasonably high salary. So in the where clause, you can use these logical conjunctive operators, like and it's a logical operator. You can use or as well. And so the two main logical operators that are used are and the other one is or. So, for example, you wanted to see these people who are highly paid workers in MIS. So you want to see that in the result set. But you also want to see, let's say, people in the accounting department who are, let's say, people who make less than a certain salary. So in the result set, you want to see both people in the MIS department who are well paid and people in the MIS accounting department who may be not that well paid. So you can keep adding ands and ors to make the filter as specific to what is it you want to grab from the data set. So here is, we want people from the accounting department who are perhaps making not as much. So I'm specifying another condition. So this will get me people from the accounting department who are making below 75,000. And I'm ORing these two conditions, which means in the result set, I'll see either people who are in this category, or I'll see people who are in the second category. So if I were to hit the execute, so I see here that, well, yeah, these are the higher paid people in MIS, and looks like there is only one person in the accounting department who makes a salary below 75,000. So the point here is that you can define any kind of an arbitrary filter with as many ands and ors as you want. Okay. The next thing, so we work through, I'm working through basically the um, the sample queries so that you get a feel for how SQL works. The next thing that we're going to cover are arithmetic functions that are used in SQL. So oftentimes you want to find like the average of something or the maximum of something. Let's say we wanted to find the average salary of people, um, average salary of people in the company. Maybe you don't necessarily have to specify the where clause. The where clause is not mandatory. Let's say I want to find the average salary of people in the company. So the arithmetic function for that is average. The four main, we'll cover the four main arithmetic functions that are used in SQL queries. So if I were to launch a query like this, select average salary from the employee database, and I do not specify any filter, I do not restrict the focus to marketing or accounting. I'm basically wanting to grab all the employees in this query. So if I were to execute this, you basically get back a result. And this is essentially telling you that um, the average salary of all the employees in this firm is 91,700. Now you could have indicated a filter here as well. So you could have said department equals marketing. So this would then give you department equals marketing. This would then give you the average salary of all the people who are in the marketing department. So if I were to execute this, so I see here the average salary of the people who are in the marketing department is 96,571. Now notice something. When we get this result set back, we have this kind of an interesting feature here which says no column name. Previously, we didn't see that. We didn't see something that said no column name. The reason for this is simply that the result that we are returning here, which is the average salary, is not already a column in my table. My employee table has no column that says average salary. It has a column for salary, it has columns for many other things, but it does not have a column for salary. So so the capability that SQL, now you don't want to send back something that says no column name, because oftentimes queries may be written by one person, some maybe perhaps a more technically savvy person, but they could be used by other people in your department. So you are a major with accounting and information systems, double major. You could be the person who ends up interacting with the databases. SQL is the common language for doing that. But perhaps older and less technically savvy people in your organization may be using your queries. So if you give back a result set with a no column name, no, that's not good, because the person using it doesn't really know what that pertains to. So the capability that is available here that SQL offers is something called aliasing. So what you can do is you can define an alias, which means you can basically give it a name. So you can call it average marketing salary. So now if you were to execute this query, you would see here, well, now people can see, you don't have to write out the whole marketing. It's understood with the MKT, it's the marketing department you're referring to. So the alias doesn't have to be a huge, long alias. It can be abbreviated to some extent. Okay, so now you see the result, which is meaningful. Well, okay, so this is the average marketing salary. If you wanted to, so the other commonly used functions, if you wanted to find the maximum salary of the people in the marketing department, what is the maximum salary? If you look at the people in the marketing department, who's paying the most? What's the maximum salary? So this would be select max salary, and of course you would want to replace the alias. You don't want to call it AVG anymore. That would be misleading to somebody who looks at it. So you simply replace the alias by MAX, max marketing salary. And now if you were to execute this, the result that you get back is max. This is the maximum salary in marketing. Couple of other functions, min salary. So max, min, average, and count. Those are the most commonly used arithmetic functions in SQL. And replace the alias, make it min marketing salary. And this would give you, if you were to execute this, this would give you the lowest salary of all the employees in the marketing department. Another function that is commonly used is the count function. So if you wanted to count the number of employees in the marketing department, how many employees are there in the marketing department? Well, the syntax for that is count star. That's the syntax for finding out how many employees do you have. And since we have specified the filter, well, here you're looking for the employees in the marketing department. So again, you can replace the alias with something meaningful. So this would be, so take out salary from there. So num marketing, it kind of indicates, or if you want to be more precise, or you can certainly put number in there as well. So this will give you the number of people in the marketing department, which is 7. So those are the 4 main arithmetic functions that are used. Let's go back to the sample queries and let's look at some other capabilities of SQL. Order by. Let's say you wanted to find out the name, department, salary, date joined. And you wanted to do this. You want to find this out for the person who's in marketing, but who makes the highest salary. So the way that is done is you add an order by clause. So if we wanted to order these employees by salary, either in ascending order or descending order, so you would use that order by clause. If you wanted to order them in descending order, then you would say order by salary, DESC, descending. And if you execute this, you will see here that, well, these are the people in marketing, and you can see the records are arranged in descending order. You could have changed that to a descending order of salary. So the person who makes the most, and then less and less and less. You could have changed that to ASC, which would give you the result set in terms of the ascending order of salary. So if you were to hit and execute here, you would get the records in the ascending order of salary. So our original question was, how do we see this information? How do we see this information, name, department, salary, for the person who made the most? Well, you order them in terms of salary. So you order the records in terms of salary, and then you simply select the top one. So the syntax here is select top one. And if you were to execute this statement, so now you see you're getting back information, but precisely about that person who's making the most. So this is the use of the order by clause, and it is typically used in conjunction with, unless you want to see the information for all of the people in a certain set, like the people in the marketing department, and ordered by a certain criteria variable, like the salary is a criteria variable you can use for the ordering. If you wanted to see all of the people, then you would not use this top one. So if you wanted to see all of the records, then you would not use the top one, and you would execute the query in that fashion. And you will get back all of the records that meet this filter. So you're getting back the records of people in marketing that meet that filter. And so getting all of the records back. But what if you're not interested in seeing all of the records ordered? You're just interested in seeing the person who makes the most, then you would simply use top one. If it turns out that there are people who may be tied, there could be two people or three people who make the same maximum salary. In this case, it seems to be 130,000. Well, what if there were two people or three people who made 130,000? So one variant of that select top one is to issue that command as select top one with ties. Select top one with ties. In this case, we have exactly one person who seems to be making that 130,000 amounts. So here, the execution of this query, even if you added the select top one with ties, does not affect the result set. Suppose you wanted this information about the person who makes the lowest. So by using this form of the query, you get this information, name, department, salary, date joined, about the person who makes the most. But what if you wanted to find out this information about the person who makes the least? Well, then what you would do is you would change this qualifier from DSC to ASC. ASC stands for ascending. And if you're ordering the rows in ascending order of salary, and you're selecting the top one, that means you're getting the person who makes the least. So you're essentially getting information about the person who makes the least. Okay. So we talked about that, order by ascending and descending. We talked about group by. Suppose we want to find out the average salary by department. So we want to know what is the, in this case, if you look at the database, there are three departments. Essentially, everybody is in one of three departments. The three departments represented are accounting, marketing, and MIS. Suppose you wanted to see as the result set the average salary in one single result set. Not, you don't want to issue three different queries. Yes, we have issued three different queries. It says select average salary from the employee where department equals marketing, and then another query which says where department equals accounting, then another query where the filter is where department equals MIS. But then you would have to issue three queries if you wanted to find out the average salaries in those three departments. How do you combine it into a single query? do that through using the group by clause. So with the syntax of the group by clause, it works like this. So we select what you specify in the select clause. This is what you get back. So what you're specifying, the column you're specifying in the select clause is what you get back. That's what you see in the result set. So we want to get back the department. We want to see what the department is, and we want to see what the associated, what the salary for that department is. So the average salary for that department. So we're using the arithmetic function AVG. Now we are grouping the records by department. So what this SQL query is doing is, you got a bunch of records. You got 30 records maybe in your employee table. Maybe 10 of them belong to accounting, maybe 12 belong to marketing, 8 belong to MIS. So what this group by does, it groups the records by whatever is the criteria variable here. So now we're saying the criteria variable is department. So it's going to group the records by department. It's going to form a group of marketing records. It's going to form a group of accounting records. It's going to form a group of MIS records. Then once it has formed those separate groups, then it's going to apply the average, the operator average, the arithmetic operator for finding the average salary, which is AVG salary. So after it has formed those groups, then it applies the arithmetic operator, whatever you have specified. In this case, we have specified average. We want average salary. So the way this would execute is you would see here department, and then you have the average salary. And again, since average salary is not a field or a column in the table, the employee table does not have a column called average salary. So therefore, we would have to give it an alias. And simply the alias, we've learned how to do that. So you're simply saying average salary as, and then you indicate what the alias is. So you give it some name. So this is average department salary. So average department salary. So now if you were to execute this, so you see here, you get the department and the average department salary. You could actually also, you can get more fancy with the group by. You could have indicated multiple variables in the group by. In other words, if you look at the database, you look at the employee database. So if you look at the employee database, you find that you can group people by department because people belong to departments. You can also group people by position because people are either workers or supervisors. Well, what if I wanted to find in the result set, I want to get back a result that tells me what is the average salary of supervisors, what is the average salary of workers by department. In other words, I want to know in the accounting department, what is the average salary of the supervisors in the accounting department and the average salary of the workers in the accounting department. And so on. So if you're in the marketing department, well, I want to find out what is the average salary of the supervisors in the marketing department and the average salary of the workers in the marketing department, and so on for the other department as well. So there, what you're basically doing is you're going to group by not just department, but also by position. So you can have multiple variables. You can have multiple variables in the group by clause. So what you would want to see here would be, so the department, the position, department position, average salary, and again, you have to give the average salary an alias, and you can, but the alias should be different. Here, we're looking for the average salary in the department by position. And it's not necessary to put the by in there. It's understood. So we don't put those, those articles and propositions and that kind of thing. That is understood. Okay, so if you were to execute this, the way this would run is it gives for you. So it tells you that in the accounting department, the average salary of supervisor is this. In the marketing department, the average salary of supervisor is this, and for MIS. And then it also gives you the average salary of the workers in the departments. So you can use this capability of grouping by multiple variables, multiple criteria variables, and then get the kind of result that you want. Okay, I'm going to stop here. So last time I left off with the group by clause. So where is the group by clause used? Well, suppose you wanted to, you've got employees. So if we look at the employee table, see what is inside it. So if we did a select up 200 rows, we can look at what is inside the employee table. So you've got employees that work in different departments. In fact, there are 3 departments represented here: MIS, marketing, and accounting. And so you can group these. Suppose you wanted to find out the average salary by department. Then you can basically group the records in the employee database by department, and then find the average salary within each of those groups. So if we were to do that, so launch a new query. So what we want to do is we want to find what is the average salary by department. So essentially what we would do is we would select department. We would select the average salary. And as average salary does not have a column in the database, so therefore we have to alias it, which means we have to give it a name. So you can say here simply average department salary, and then from the employee database, and you're going to be grouping by department. So group by department, and this should give you basically the average salary by department. So if we were to execute this, we see here, of course, we don't want so many decimal places. So to get rid of the decimal places, simply use the round function. So this is round, and you're rounding it to 0 decimal places, which means you're rounding it to an integer. So that's why the second argument to the round function I'm giving as 0. So now if we were to execute this, we find what the average salaries by department are. Suppose we wanted to find the average salary for the department that has the highest average salary. So I don't want to see all the departments and their average salaries. Let's say I want to see that department whose average salary is the highest amongst all of the departmental average salaries. Well, to do that, you can simply add an order by clause here. And you could order by average salary and do an average salary descending, and then select the top one. So if you did this, you essentially get the department which has the highest average salary, which is the marketing department. Also, you can group by more than one uh, grouping variable, if you will. So we could have grouped by department, but we also know that all our employees have been classified as either workers or as supervisors. So if you look at the employee table, you notice that all our employees have been classified. They're either workers or they're supervisors. Let's say for each department, we wanted to find the average salary of the supervisors. So for the marketing department, we want to know what the average salary of the supervisors in marketing is. Um, we also want to find out the average salary of all the workers in marketing. Similarly, we want to find the average salary of all the supervisors in accounting and workers in accounting and so on. You can group by more than one variable. So if you want to do that, if you want to find the average salary by department, by position, then you could have grouped by more than one variable, and this is in the in your SQL queries. I'm basically going through this document, so all these queries that I'm doing is actually there in your document here. So this is the query for how we would group by department, and within the department, how would we group by position? So if we were to go back to so I want to find for each department and each role or position belonging to that department. So select department position, and then of course the average salary. The department position, average salary as average salary. And this is from the employee table. And it'll be grouping by um, department, and within that by position. So that's written as position, department. So this is kind of the syntax for it should be grouped by. I was wondering why I was getting this squiggly error. So yes, it should be grouped by. So this is the syntax for multi-criteria grouping, which means grouping by more than one variable. So here we're trying to group by department, and then within that department, we're trying to group by position. So if you were to execute this, you would see here the average salaries. So for the accounting department, the supervisors have an average salary of this, the workers have an average salary of that, and so on for the rest of the departments. Okay, that's the story about the grouping clause. Now let's work through the remaining. Um, so I don't think we are actually using, or we might be. So okay, let's talk about pattern matching. So let's say you wanted to find um, all the employees whose address contains the word drive in it. So we want to find employees whose address has the word drive in it. Okay, so we want to know some things about that employee. So let's say we want to know, the name of the employee. We want to know the name of the employee. We want to know the address of the employee. So the name, the address, We want to know their department. We want to know their position. But we want to know this for employees who are living in an address which has the word drive in it. So the where clause, the way the where clause would be written for that kind of a filter is where address like percentage sign drive percentage sign. Let me first execute this query and then I'll kind of explain what these percentage signs are trying to do. Okay, we want to know the employees who live on whose addresses have the word drive in the address. So you see here, we have picked out exactly those employees who live on street addresses which has the word drive in it. And so we try to match a pattern. So we're looking for a pattern that looks like this. What the percentage sign signifies is it signifies any number of characters. So what we're doing is we're looking for a pattern that has any number of characters and then the word drive in it, and then any number of characters after that. So we're looking for an address that matches this kind of a pattern. Suppose I had not, sorry, why this thing keeps coming up? Suppose I had not put the, suppose I had not put the percentage sign here. So let's say I took out the percentage sign. What you would we do have the problem with VLAB, as we have noticed earlier on, but give it some time and the VLAB does come back. Okay, let me actually go to a slightly different computer here. Okay, so it did come back. So if we took out the percentage sign, well, then what we're trying to say is we're trying to look for an address that has only the word drive in it and nothing else. Well, if we were to execute this query, you'll notice that we get back a null set because we don't have, or we get back a null set because we don't have any address that has only the word drive in it and nothing else. We have addresses which have a whole bunch of characters before the word drive and a whole bunch of characters after the word drive. So for example, if you were to put a percentage sign here, and if we look for a pattern that is of this nature, percentage sign, which signifies that there can be a whole lot of characters before the word drive, but we didn't put an ending percentage sign. Well, that means we're looking for an address which has a whole bunch of characters before the word drive, but after the word drive, there are no other characters. Well, this if we executed that again would give us the null set, because our addresses match patterns where you have a bunch of characters before the word drive and a bunch of characters after the word drive. So we have these 4 employees whose addresses match that kind of pattern. Okay. Let's talk about what we haven't talked about is a very, very important thing, which is joining of tables. So let's talk about that. So let's say we wanted to see some information about employees. Maybe these are employees in the marketing department. So department equals marketing. So we want to see employees in the marketing department, and we want to get some information about them. Let's say we want name, address, department, position, salary. We want to get all this information about them. But we also want to get what is their performance rating. Well, this information can come from, so if you want to also see what their performance rating is, well, the performance rating is not in the employee table, 1,000 rows. The performance rating is in that table, the performance review table. It's not there in the employee table at all. So if we want to get the performance rating, if we had just specified the SQL query in this fashion, it's going to give us an invalid column name because the performance rating is not in the employee table. So what is done is that we join the two tables. We have an employee table with some information in it. We have a performance review table with some other information in it. Now, when you want to gather information from both tables, so we want some elements of information to come from the performance review table, come from the employee table. What we have to do is we have to join two tables. And in order to join two tables, there must be a common column, meaning there should be a column in let's say the left-hand side of the join, which should have the same values in the right-hand side of the join. So by that I mean that we're joining two tables. The left-hand side table is employee T, and the right-hand side table is performance review table. We're going to join these two tables so that we form an elongated or an extended table, and then we can essentially get the information we need from the extended table. So the syntax of the join is employee table, that's the left-hand side of the table. So inner join, and then the performance review table, which is the right-hand side table in the join. We have to specify to the database management system what is the column that is common. You see, if you look in the employee table, you have here. If you look in the employee table, you see here there is the SSN column, which identifies uniquely the employee. So there's the SSN column that is in the employee table. If you look in the performance review table, and do a select 1,000 rows, again you see here the SSN is there. So there is a common column across these two tables, and the join is done on the basis of that common column. So what is done is, in joining the two tables that we are trying to do here, I've got too many things, too many windows open. So let me just close a few of the windows. So we were trying to join these two tables and form this elongated column. Now we have to specify to the database management system what is the column that is common across these two tables. And looking at the tables, we just saw that the SSN column is common across the two tables. The SSN column is there on the left-hand side table, and it's also there on the right-hand side table. So to complete the syntax of the join, where we have to specify to the database management system what that common column is, so it's written as on employee SSN equals performance review table dot SSN. So it equals performance review dot SSN. So this is the syntax, this whole thing here. This is the syntax of how you join two tables. Essentially, what we are telling the database management server to do is take one of the is to take one of the tables, the left hand side table, pick a record from there, look at what its SSN value is. So pick a record from the employee table, look at its SSN value, then find the corresponding record in the performance review table, the right hand side of the join, which has the same SSN value, and then join the two records to form an elongated record. And do this for each of the records in the left-hand side table. Join them with the corresponding records in the right-hand side table and form an elongated record. In other words, extend the table. That's what the join does. It takes the table and then it extends the table by the information on the right-hand side of the join. And how's it doing it? It's doing it because there's a common column between the two tables. There has to be, in order to join two tables, there has to be a common column between the two tables. So the way it's doing it is it's taking a record on the left-hand side table, and it is then examining, well, here, what is the SSN of that? This is the column that is common across the two tables. So it's examining what is the SSN value for that record, and then it's finding the matching record, the corresponding record on the other side, and essentially then it's finding the matching record on the other side, and it is then forming that elongated or extended table. Now, if you were to execute this, okay, so this is so I seem to get a slight error out here. So incorrect syntax from, all right, so let me do this again. From employee T, we're trying to join the so employee T inner join performance review on employee T SSN. All right, let me try and see what the syntax error here is. One has to wrestle with queries to get them there. Okay, so the syntax does work. So essentially what we're doing here is we are trying to join the two tables, the employee table with the performance review table. And there's the common column, which is the basis of the join. To join two tables, you have to have a common column, which has the same information on the left-hand side table and the right-hand side table of the join. Here, the common column is SSN. SSN is there in both the employee table and it is there in the performance review table. So we are indicating to the database server that the basis of the join is the SSN. So essentially what the database server has to do is it has to go and pick a record from the employee table, the left-hand side of the join, look at its SSN value, and then find the matching record on the right-hand side table and join the two records to form an elongated record. And do this record after record in the in the left-hand side table, find their matching counterparts in the right-hand side table, and basically then you get what you get is an extended table. From this extended table, which is written like this, the from, now you can essentially get all these get all the values that you need, like the performance rating, which was not there in the employee table itself, but is there in the elongated or extended table. So now you can specify all of the columns that you're interested in. You could certainly also have the where, so you could certainly also put the filters. You can put the filter on the extended table. So let's say you're only interested in the Department of Marketing. Well, then specify a where clause. And now you will not get here, you're seeing the information from all departments, but now if you wanted to restrict it, here now you see the information from just the people who are in marketing, but you're getting their performance rating as well. If you wanted their percent salary increase also, the percent salary increase is also in the performance review table, but it is not there in the employee table. So, but now that we have formed an elongated table, an extended table, which has all of the columns, both from the left-hand side table, employee, and the right-hand side table, performance review. So now we could also add other things like the percent salary increase. So let's say we also wanted to get the percent salary increase. Well, then we can add that, the percent salary increase. Okay. Now, if we were to execute this, we would see here we get we get all the information that we want, and we have gathered this from two tables, not one table. Just a matter of terminology. When you write something like this, employee T dot SSN, this is also known as the fully qualified name of a column in the table. So a fully qualified name of a column in the table is the table name dot the column name. That's also known as the fully qualified name. And when you're working with tables that have been joined, you may have columns that are repeated across the different tables. For example, the column name is there in so many tables. There's a name of this. You'd be working with a courses database. There's name that appears in the student information table. There's a name that appears in the professor information table. Of course, in the student information table, the name signifies the name of the student. In the professor information table, the name signifies the name of the professor. But how do you keep the two apart when you're using some sort of a complicated join with three or more tables joined together? The way to distinguish and keep these names apart is to keep the column names apart is to use fully qualified names, which is the table name dot the column name. So this little syntax here is actually also referring to the fully qualified, is referring to a fully qualified name. Is null. So this is also important. So let's say sometimes we want to find records that have null values. So there is in the performance review table, if we look at the data inside the performance review table, there is, you see here, there is a person here that has not been given a salary increase. So the salary increase field is null in that case. So let's say we want to find people who have not yet been given a salary increase. We want to know why not. Maybe the supervisor left or something and neglected to complete their job of giving salary increases. So oftentimes you're actually interested in finding in finding records that have a null value in certain columns. So if we want to find information about somebody whose percent salary increase is not there, it's null. So we can specify a filter, which is percent salary increase. And you can actually also pick it up from here. Percent salary increase is null. Or it's probably written like this, is null. So if you were to execute this, you see here you get back the information about the worker who has not been given a percent salary increase. So comparisons, so far, we have set filters where we are comparing um, the value of a column to some specified value, where that specified value could also be null. And often that type of comparison is important as well. Okay, in the last question, we saw how to join tables. We joined the performance review table and the employee table. Let's look at a more complicated join where we have to join more tables. So we go to if we flip to our the student course registration database that we have 4 tables in there. And let's look at this question. Get the student name, major, course name, department, GPA, professor name, contact information, contact number, the professor's contact number, for the student Bill Riley and the courses that he took in his major where he got a 4.0. So we want a whole bunch of information about Bill Riley's performance. We're looking for where he got a 4.0 in his major. So we're not looking at other courses that he may have taken. We're looking at courses in his major. And so that means, well, we have to join the student information table and the courses taken table because, well, the student name and major comes from the student information table. Courses that he took from various departments and the grades that he got comes from the courses taken table. So those 2 courses will have to be joined. Those 2 tables will have to be joined. Now, we also want to know what was the course name in the courses that Bill Riley took in his major where he got a 4.0. What's the name of that course? The course name information does not reside in either the student information table or the courses taken table. It resides in the courses table. So the courses table has to be joined into this to the 2. So far we have a 2-way join. Well, now we have to bring in and make it a 3-way join. And there is a common column between courses table and the courses taken table, and that's the course ID. So we'll use that as the basis of the join. Now they're also asking for the professor name and contact number, and that we can only get through the professor information table. So we'll have to join that to the join that we have so far and make it into a 4-table join. And then we can get the information required. So let's switch back to the Microsoft Management Studio. The SQL Server Management Studio, as they call it. Okay. So let's see here. Let's do a new query. And so the first thing is, well, let's do all the joins needed. So select from, and we said all the 4 tables will need to be joined. So let's start doing that. So the student information table is the first table in the set of joined tables. This is, I need to flip this to the courses DB. Okay, so the student information table, and this is going to be joined with the courses taken table. Joined with the courses taken table. And on. So here's where you specify what is the common column that allows you to join the 2 tables. You must have a common column. The name of that common column may not be the same, but the information is. That's how you join the 2 tables. So the common column is student ID between the courses taken table and the student information table. The common column is student ID. So this is equal to the courses taken dot student ID. Now, we have to bring in the other tables as well, because the course name actually comes from the courses table. And there's a common column between the courses table and the courses taken table, and that is the course ID is the common column between those 2. So this So inner join, the courses table. So got to make sure the syntax is all correct. So inner join, and here is the courses table. We're going to bring the courses table into the join, and on. So on courses taken table ID, and the courses table has course ID as well. That's how you join the courses table to the course ID table. Okay, and this is inner join. Okay, looks good so far. Student information, inner join with courses taken on student information, student ID, courses taken, student ID, and then inner join further. The courses table on courses table dot course ID equals, this should have been courses taken. So courses on courses table dot course ID equals courses taken dot course ID. Course ID is the common column between courses table and courses taken table. And finally, we also have to bring in the professor information table. And the professor information table also has a common column with the courses taken table. We have the professor SSN in the courses taken table, and that matches the SSN column in the professor information table. Okay, and so professor information table dot SSN to be equated to the courses taken table dot professor SSN. The common column need not be across the two tables, need not have the same name. Often they do not. But they have the same information. So here we have the professor SSN in courses taken, and the values in the professor SSN table match values in the SSN column of the professor information taken. So now we have done the join, the four-way join, and now let's see what is the information they want. So they wanted, first of all, restrictions are that the student in question is Bill Riley. So the first thing we want to do is we want to make the student in question Bill Riley. Notice I'm using what are known as fully qualified names, which is the table name dot the column name, because the same column name, particularly for common column names like name, can appear in more than one table. So here we're looking at student information name, Bill Riley, is equal to Bill Riley, and the offering department, which is the courses taken dot department. This is the offering, this is the department from where he took the course. And the offering department must be the same as his major. Notice one thing, I didn't use the full, I used the fully qualified name for courses taken dot department, because department is again, that column name is again used both in the courses taken table and also the courses table. But I didn't do that for major because there's no, the word major, that column heading is not repeated in any of the other tables. So when you're sure that it's not repeated, you don't have to do specify a fully qualified name. And then also we have another restriction, which is GPA is equal to 4.0. And again, I didn't use the fully qualified department equals major, and GPA equals 4.0. I'm not using the fully qualified name in GPA either, because again, GPA is not repeated across the different columns. And now you simply have a look at, well, what is the information they wanted? That's what you put after the select statement, after the select clause. And so what information did they want? So they wanted the student information name. They want this. be displayed. They want the student's major. They want the student's major. They want, go back and see what else do they want. They want the student's name, major, course name, department, GPA. So they want the course name as well. So the course name where that is in his major and where he did very well. So they want that course name. They want to verify the department. So you can say courses taken, department. You want to verify that the offering department was indeed the major. So they'd like to see what is the offering department. Since they're listing in the major as well, they can compare the two and see that the two are indeed the same. Okay, now the GPA. Make sure that we're only looking at a course with that GPA. And then the professor's name as well. So the professor's name here is, and then they also want the contact number of that professor. And I used the fully qualified name for professor information, but for contact number, I know that that's unique. So here I don't really have to use a fully qualified name for that. Okay. If you see all these red squiggly marks disappear, then that means your query is syntactically correct. Otherwise, you'll see those red squiggly lines, underlying several of these, identifying the various syntax errors that you made. Okay, now if we execute this, essentially what we get here is that Bill Riley's major is management. He took a course from the Department of Management, which is this information systems course he took. He took it from me and his contact number, and my contact number is this. So this is a more complex multi-way join, which I wanted to show you as well. The next thing that I'd like to show you is the case statement. The case statement is actually very useful in generating new columns. So for example, if you look at the employee database, if you look at the contents of the employee database, so let me just bring that up. So the employee table, and let's look at the contents of this. So as you see here, we have SSN, name, address, department, and so on. Now, what if we wanted to actually generate state as a column? We're not interested in the entire address. We're interested in the state of the employee, the state that the employee lives in, because we want to do some arithmetic calculations on state. For example, we may want to find out what's the average salary by state. This kind of thing can be done by using the case statement. And we'll also do some pattern matching. So basically, if you're trying to find the people who live in Massachusetts, you're trying to find the pattern, comma, the patterns after the city, there's a comma, then there's a space, then there are two characters. So people who live in Massachusetts will have the pattern in their address for a comma, a space, the two characters MA, and then a space. So we look for that pattern. And if there's a match, then the state of that person is Massachusetts. We'll generate the state as MA. If we look for the pattern NH and we find that, comma, space, NH, space, then we will generate the information in the state column as NH. So let's see how this thing works. So let's do a query, new query. And our goal is to find out, we're not interested in the entire address. We just want to find out what's the state in which the employee lives. So, so we're selecting from, and some other information. We're selecting from the employee table. And Now we have to generate the column state. So this is done by using a case statement. The case statement has a structure like this. It begins with the keyword case, and it ends with the keyword end. Now, here's where we put in the individual conditions. So when address like, I used to the pattern matching, a few questions previously. So now we're looking for the pattern. It can begin with any number of characters. And we want to get to a comma followed by a blank, and then followed by the two characters MA, then followed by a blank, and after that a certain number of characters for the zip code. So if we find that the address field has a pattern like this, that means we know that this person resides in the state of Massachusetts, and then MA. The next condition, now maybe this condition will fail. Then we'll go to the next condition. So then if the person resides in New Hampshire, so here we'll replace MA by NH. If the person resides in New Hampshire, then this is NH. If the person resides in Rhode Island, then this checking for whether address like this, and if it is that, then it's Rhode Island. And then we can, and now this is the column heading. The column heading has to be specified. So this is basically giving that column the heading, and you can just call it the state. And then we can look at other things we may want to look at. We may want to look at the salary. We may look at the position. Okay. And now when you execute this, what you see here is the state. You have the employee and their state, salary, and position. Let's say you wanted to verify that these are indeed the real true states. Well, then you could have introduced the address just for the verification purposes. We can drop address once you get to a problem. If it doesn't specify address, you can simply drop that. The syntax error that we made here is that we should have followed that by a comma. So now if you execute this, now we're adding the address here just for verification. Now you can see here, James Doherty, yeah, his state is Massachusetts. Beth Simpson, Massachusetts. Susan Kaufman, New Hampshire, and so on. So you can see that the states have been correctly generated. Rhode Island, and it was done by this piece of logic, if you will, the case statement. And this is the syntax of the case statement. Okay, so that's your question number. That's in the basic queries. That is actually question number 18. So question 18 was get the employee name, state, salary. Now question 19 is what if we wanted to get the salary by the average salary by state. Now, one powerful capability of SQL is something called derived tables. What derived tables mean is that the output of a SQL query, this output of a SQL query that you see right here, this can be treated as a table. And then you can select from this table. So if we can treat this as a table, then all we're going to do is do a group by, and then find the average salary by group. So a group by state, and then find the average salary by group. We have seen the group by application before. So to do this, essentially, we can treat the output of select statement as a table itself. It's called a derived table. and then do the selection from the derived table. The derived table can basically be treated as just as any other table. Now the derived table, so what we're doing is, this was our select statement, which resulted in that output. Now we have, so by putting the left parenthesis and right parenthesis around this whole select statement, and that makes the derived table, then you have to give that derived table some name. Don't call it something, just call it table 1. That's fine. Call it table A, whatever you like. And now you can select from table 1. So now here you can select, and you want to group these records in table 1, which is the output of the select statement, the previous select statement. We want to group them by state. So we can have here a group by state. You can group them by state. And then we are basically selecting from table 1. So this is select from. So be careful of all these syntaxes. So this is the table 1. We are selecting from that table 1 and selecting state and the average salary. And this will become, if I give that an alias, and this will become our average salary by state. You don't really have to put the by in there. You can simply say it's average salary by state. And if you execute this, what happens is we get the average salaries by state. We could have, if you wanted to find, let's say, by state and then further break it down by position, we could have done that as well. So by state and then by position. So let's say the outer grouping should be state and then the inner grouping should be by position. If you want to do that, you could have also done that. Then this would be state and followed by position. And this would actually give you groupings by state and position. So you see here, Massachusetts, the average salary of supervisors in the state of Massachusetts is this. Average salary in the state of average salary of workers in the state of Massachusetts is that, and so on for supervisor. So this is the use of the derived table. Okay.